So this is our review question. And so firstly, we are going to see, we have like 4 parts, right? Part 1, part 2, part 3, and part 4. So part 1 and part 2, they are for, they are like some short answer, okay? You can just write your answer directly here. And for part 3 and 4, you have to explain every single line, okay? Stuti, can you hear me?
Yeah.
Okay. So for part 1 and part 2, you have to write the answer only, okay? And for part 3 and 4,
We don't need to show the solution,
right?
right? In part 1 and part 2.
Yes. So the first
Or
one,
we need to show the solution.
yes, right.
Hmm?
Yeah, we need to show the
In part 1 and part.
no. In part 3 and part 4, you have to show the solution. But for part 1 and 2, you don't need to show the solution, okay?
Just the answer.
Yeah, just the answer. Yes. For part 1 and part 2, just.
Okay.
So firstly, we have limit. We have to find limit x tends to -1. Limit x tends to -1, 3x into 2x minus 1. So you see here, we can directly put our value here, right? We can directly put the value of x here, because if we put the value of x here, x is equal to -1, so it will be 3 into -1. 3 into -1. Yeah, 3 into -1 into 2 into -1 and -1. So altogether it will make 9. Okay. So we can directly substitute the value here. Okay. So if we substitute the value here, x equal to -1, so 3 into -1 into 2 into -1, that means -3 into -2 -1, right? So it will be -3 into -3. So it will be -9. It will be 9, right? So this is the answer of number 1. So number 2, we have 2 minus x square. G of x is greater than 2 minus x square, greater than or equal to 2 minus x square, and less than or equal to 2 cos x, right? For all x, then find limit x tends to 0 g of x. So you see here, our function is here, but we have one function here and another function here. That means it's something like a sandwich, right? So here we have to apply sandwich theory. So
How to apply sandwich theorem?
let me show you. So to find sandwich theory is, we have to find the left hand limit and right hand limit. Okay, the left hand limit and right hand limit. So I have to open side by side, but it is opening here. Let's cross this. So our left hand limit is here, and our right hand limit is here. Okay. So you see here, the value is limit x tends to 0, right? That means we have to input the value x equal to 0 here, right? We have to plug in the value x equal to 0 here. Okay. So 2 minus 0 squared. 2 minus 0 squared, it will be 2. And 2 cos x. So if you plug in 0 here, so 2 cos 0 means 1, right? 1. So 2 multiply 1 is 2. So you see here, on the left hand limit we get 2, and also at the right hand limit we get 2. That's why our value will be 2. Okay. So this is the answer for number 2. You got it?
Yeah.
Alamin, how are you? Always there is some internet problem. Oh, it is very disappointing. Yeah, so let's continue. So number 3, we have if f of x is equal to 4 minus x square, then the value of the derivative f derivative f of minus 3 derivative is equal to what? So firstly we have to calculate.
You cannot.
Yeah, firstly
Oh,
calculate the derivative value.
okay.
Firstly you have to calculate the derivative value. So we know that derivative of 4 minus x square. So derivative of this constant, it will be 0, and derivative of minus x square, it will be 2x, right? 2x. So now we have to plug in the value minus 3 here. Okay. So 2 into minus 3, that will be minus 6. So
Okay.
2 into, oh yeah, minus 3. Okay. So here we had another minus, right? So minus, we had a minus here. So ultimately it will be plus 6. Okay.
Okay.
Guys, you can see here. So firstly we have to calculate the derivative value of our function. So derivative value is minus 2x, and then we have to plug in the value of x. So here x is equal to minus 3, right? So if you plug in minus 3 here, so it will be minus 2 into minus 3. Minus 2 into minus 3. So minus that. Oh. Guys, can you understand this one? Hello?
Yeah, yeah.
Okay. Let's go.
I hope I can.
So number 4, we have, suppose that e to the power x is e to the power x square is an antiderivative of the function f of x. Then integration of f of x dx is equal to what? So this e to the power x square, this means this is an antiderivative, right? So antiderivative means capital F of x. Okay, capital F of x. So now we have to find integration of f of x dx. So see here. Number 4. So in our function, in our question, this one is given. Okay, capital letter f of x is equal to e to the power x square. So now integration of f of x dx, from the formula we know that it is f of x plus c. Okay, because integration means it is like, it is represented with capital F. Okay, capital F of x. So now we have to find the integration of this function. Sorry, we can just directly input the value here. So f of x, it will be e to the power x square, and we have a c here. Okay, plus c. Guys, can you understand? We had a suppose that e to the power x square is an antiderivative of the function f of x. That means e to the power x square, this is capital F of x, right? So then we have to find integration of f of x dx. So we have to explain what is integration of f of x dx. So integration of f of x dx, it is capital letter f of x plus c, because using capital letter F, we represent integration. Okay, and then you can just plug in the value. So f of x, it is e to the power x square. Okay, Guys, see here, f of x capital capital x squared. Alamin, am I clear?
Yeah, brother. You can hear me, right?
Yeah, I can hear you. Also, Stuti can understand. Okay. So let's go to next question. Number 5, we have if y is equal to integration of 0 to root over x cos t dt, then find dy by dx. That means we have to differentiate this function, okay? But if see we have integration inside of this function, right? So we have to think two way. Number one, if it is a odd function, or number two, if it is a even function, okay? So if it's an odd function, how do you understand? So we just calculate f of minus x. So if f of minus x is equal to minus f of x, so it will be a odd function, okay? And if f of minus x equal to f of x, so it will be a even function, okay? So what do I mean by that? So you see here. So we have a function integration of 0 to root over x cos t dt. So if we just plug in minus t here, okay? So cos minus t dt. So it will be cos, you can just say cos minus x, okay? Cos minus x dx. Or you can also write cos minus t dt. So you can take this minus before, right? You can take this minus out. So we get minus cos x dt dx, minus cos x dx. So this is a odd function, right? So for odd function, let me open up the previous lecture. So, so for odd function, this is the formula, okay? Oh, sorry, is this, no, this is not odd function. So when we will think about odd function, so when our limit is like minus 1 to 1, minus 1 to 1, like this way. That means symmetric, okay? When our limit is symmetric, then we will use odd function and even function rule, okay? But in this case, you see here, in this case, this is not a symmetric interval, right? A symmetric integral. Symmetric integral means integration of suppose minus a to a, okay? This is symmetric integral. So we will think about even function and odd function in case of symmetric integral, okay? But when it is this way, like 0 to root over x, so this is not a symmetric function, okay? That means it's very easy to calculate. We just need to focus on here. So you see here, we 0 to root over x. So this is like g of x. We can express this root over x as g of x, okay? G of x. So if we have something like g of x here, then we have to differentiate it, okay? So firstly, we have to plug in the value here, and then we have to multiply the derivative value of this g of x, okay? So here our g of x is root over x. So derivative value of root over x, it will be 1 by 2 into 1 by root over x, okay? So this is the derivative value of g of x. So you see here, firstly we just plug in the value, like the final answer will be cos root over x. You see here, we plug the value here, and then we multiply using the derivative of g of x, right? So derivative of g of x, this is 1 by 2 into 1 by root over x. Okay, guys. So this way we solve question number 5. is not. Okay. So, Alamin, can you understand? Mm. Istuti, can you understand?
No.
Okay. So I will explain again. And about the apps, you just need to switch on some permission. Okay, like you have to permit like
Oh,
30 apps.
okay.
Okay. So I have to explain number 5 again, right?
I don't think I will understand. Just go on to another one because it's very confusing.
Okay. So that means you can understand by your own thinking, right? Because we all think differently. So yeah, it's okay.
Yeah.
So the very simple way is just plug in the value here. So it will be cos
Yeah.
root over x, and then sorry, again the same problem, my internet. So then you multiply the derivative value of g of x, right? So derivative value of g of x, it will be 1 by 2 root over x. Okay. So this is the simple way to explain number 5. Let's go to part 2. Okay. So we have the derivative of the following function that does not equal to sine 2x. So we have to find the derivative value of all of these 4 functions, and we have to see if it is equal to sine 2x or not. So minus 1 by 2 cos 2x. So if we find the derivative of minus 1 by 2 cos 2x, so firstly we take the constant out, and then we get minus cos 2x. So we just now if we find the derivative of minus cos 2x, we can also take this minus out. Let's see here. So firstly we take minus half out of this cos 2x, and then cos 2x derivative. So this is like a composite function. Okay, because we know the derivative value of cos x, it is minus sin x, but here we have cos 2x. So as it is a composite function, that's why we have to use chain rule. Okay, so chain rule is outside inside function. So outside function is cos 2x. So derivative of cos 2x, that will be sin 2x. Okay, that means derivative of outside function, and derivative of inside function, that is 2x. Derivative of 2x will be 2. Okay, so ultimately then we can cancel this 2, and minus and minus, that makes plus. So we get sin 2x. Okay, and for
Yeah.
C and D, you see here the value is same, right? At the right part it is same,
Yeah.
and left part we have on, we have 4. That means we have some constant value. So as they are constant, so we constant derivative of any constant, it will be 0. Okay,
Yeah.
so number 1, A, C and D, their value is same. Their value is sin 2x. So we have to
Same.
find that does not equal to, right? So we have only B option left.
Yeah.
So we can just say that B is correct. Okay. Stuti, can you understand?
Yeah, I can understand.
Yeah, how about Alamin? Alamin,
Brother, there is a lot of crowd here.
you're outside, right? Okay, no problem.
Yeah, in the bus.
Okay. So let's continue. And B, if you want to calculate B, so it will be like this way. derivative of minus cos 2x. So we just take this minus out, okay, firstly, and then cos 2x. So it is again a composite function. So derivative of cos 2x will be minus sin 2x, and our inside function is 2x, right? So derivative of 2x will be 2. So ultimately the answer is 2 sin 2x. Okay, guys.
Okay.
So let's go to the next question, number 2. The following equation dash holds. So we have to see which one is correct, okay? So number A, you see we have some kind of difference here, like x tends to x, limit x tends to infinity and limit x tends to 0, right? So if limit x tends to infinity, then we can divide by the highest power, okay? But if limit does not, if limit x tends to 0, then we cannot use this formula, okay?
Yeah.
So for number A, it is limit x tends to 0. So we have to plug in the value here, okay? 0 cube means 0, and minus, if we just plug the value of x here, okay? So all these three, they will make 0, right? And
Yeah.
we only get minus 1 here. And on the downside, again, these three, they will make 0. And we get plus 1 here.
Yeah.
So minus 1 divided by plus 1. It is minus 1, right?
-1.
Simple question. Answer will be B, okay. So this one is not correct, okay? So let's see number C. If we plug in 0 here, so all this part, they will make 0. So we only get minus 1. And this part will make 0, and we get plus 1. So minus 1 by plus 1, this is also minus 1, right? So this part,
Yeah.
this statement is also not correct. And here we have limit x tends to infinity, right? So we have to divide by the highest power.
Yeah.
So if I divide by the highest power, so you see here, x cube by x cube, it will make 1, right? And also on the
Yeah.
downside, x cube by x cube, it will also make 1, right?
1.
So we get 1 by 1. So how about this one? How about this minus 1 and this one? You see here, we cannot. Okay, let me see. Take the highest. Take the constant of. Okay, so so here you see, we don't need to think about these two things because it is limit x tends to infinity, right? So we can just use
Yeah.
this formula. We can just we can take the constant of high power, highest power, right? Constant
Yeah.
of highest power from the upside and also from the downside. Or simply you can just
Yeah.
divide by the highest power. So
Yeah.
for D and B and D, we don't need to think so much because we have in limit x tends to infinity
You
here.
just need to divide by.
So
Yeah.
to make it simple, you can just take the constant of the I mean how to say, okay, so let's continue, okay? So we just need to take the constant of, we have to take the coefficient, okay? It is called coefficient, okay? So you have to take the coefficient of highest power. So you see here we have on and on here. So on divided by on, it will make on, right? Oh, they are making some kind of, okay. So this one is correct, right? And for number D, if we divide by the highest power, this is x to the power 4. So you see here, we divide by the highest power. So ultimately, we get here on by x. We get here 3 by x square. We get 2 by x cube. So if you plug in the value here, x equal to infinity, so we know that any constant divided by infinity, this is equal to 0, right? So all this part up here, it will be 0. And down here, this part will become also 0, right? So we get 0 by 1, that is 0. So this statement is also not correct. Okay?
Yeah. B is the answer.
Stuti, can you understand?
Yeah.
Okay. I'm very sorry for my internet connection, because the connection is okay, like I'm using 4G, but some problem with the mobile the network provider, I think. Sometimes the connection get lost.
Yeah, maybe. It's okay.
Yeah. And I'm using the hotspot of my mother's mobile phone, because I don't have that kind of.
Oh,
Okay. My mobile only support 3G, okay? And sometimes it becomes 2G. So that's why I need to use my mother's mobile.
Oh no, it's terrible.
Yeah, yeah. So number 3, my mother is more smarter than me. Okay. Number 3, suppose that the function f of x is sine x by x, where x is not equal to 0, and when x equal to 0, then it will be 2. Then the function value is 2. Then x equal to 0 is dash of f of x. So we have to think like, okay. So we have to, firstly we have to look at the answer, okay? Continuous point, jump discontinuity, removable discontinuity, and infinite discontinuity. So you see here, we have 3 discontinuity, right? And if I want to draw a graph, so discontinuity means, suppose here is some hole, right? Or something like here is this function is not smooth, right? We get some kind of corner here. So a continuous function is always smooth. Sorry, a differentiable, the function that is differentiable is always smooth. Okay, you can see here our Laushi told us a differentiable function should be always smooth. So here we are just talking about, we are not talking about differentiability, we are talking about discontinuity and discontinuity. So if our left hand limit, our right hand limit, and our function value, okay, if they are same, then we can say that this function is continuous, okay? And if they are not the same, then they will be discontinuous. And there is some kind of classification of discontinuity, like jump discontinuity, removable discontinuity, jump discontinuity, and infinite, okay? Infinite discontinuity. So we have to see if our left hand limit and right hand limit, they are equal, but the function value is not equal to them, okay? And this is for the removable discontinuity. And for jump discontinuity, the left hand limit and right hand limit, they are not same, okay? So if our left hand limit and right hand limit, they are not same, we can just say that they are jump discontinuity, like it was a function, so it just jumped from here to here, okay? You see, it jumped from here to here.
Yeah.
So something like this way, this is called jump discontinuity. So when our left hand limit and right hand limit, they are not the same, then we can say that this function, this is a jump discontinuity. Okay, so let's calculate here. This is number 3. Okay, so we have x equal to 0, right? So to find the limit,
Yeah.
we have to take this function. So limit x tends to 0. So x tends to 0 means x is not equal to 0. Am I right? If x equal to 0,
Yeah.
if x is equal to 0, then we have to take this function, right? We have to take y is equal to 2. You see here x equal to 0, then y is equal to 2. But when x is not equal to 0, then we have to take this function on the upside, sin x by x, okay? So that's why we take sin x by x. That's why we don't take 2, okay?
Yeah.
Yeah. So I can write down this way: limit x tends to 0 where x is not equal to 0, f of x. Okay, so we just take our function here, sin x by x. So if you plug in 0 here, if you plug in the limit here, so it will be okay. So let me calculate. Okay, so if you plug in the limit here, so it will be sine 0 by 0, right? So sine 0 by 0. So this will make something like 0 by 0, right? So 0 by 0 form is undetermined. So there is another, so we have to think another way. Like we have to differentiate on the upside and also on the downside. So derivative of, okay, we can think another way. This is a formula. Guys,
This is the formula, right?
limit x tends to 0, sin x by x, it is equal to 1. This is a formula, okay.
Yeah.
So, but if it was not a formula, then we had to think like so deep, okay. So we get on and our function value. So we have to see where x is equal to 0. The function value will be found where x is equal to 0, okay. So we see here x is equal to 0. Then our function value will be 2, right?
Yeah.
Let's see here where x is equal to 0, our function value is 2. So they are not the same. Our left hand limit and right hand limit and our function value, they are not the same. So if it is not equal to
Jump.
that means it is removable discontinuity, right?
A left-hand limit and right-hand limit is not equal, right? Then it should be jump, I guess.
So guys, can you see? It is a removable discontinuity.
How?
Stuti, you don't understand?
Because
Okay,
how come it's removable discontinuity?
so to find removable discontinuity, we have to see if the limit, I mean the left hand limit or right hand limit, they are
Yeah.
similar to the function value, okay.
Mm.
We have to check. So you see
Okay.
here that the limit is the left hand limit and right
Yeah,
hand
yeah, I
limit are
understood.
1, okay.
I got it here.
And but their function value is 2. So they are not similar, right? On and 2, they are not similar. That's why we have to
Yeah.
say it is removable discontinuity, okay.
I will join a few minutes later.
Okay, no problem, Alamin. So do you understand now?
Yeah.
Okay. So let's continue to the next question. So let me write down very simply here. So it was function value limit. It was limit. Oh. So removable discontinuity, it means limit x tends to 0, f of x, this is not equal to function value, right? And for jump discontinuity, it is our left hand limit, that means limit x tends to x naught plus x naught minus is not equal to limit x tends to x naught plus, okay, f of x. So guys, can you understand now? Hello.
Yes, I can understand. Yeah.
So number 4, we have the indefinite integral integration of cosec squared 2x dx is equal to what, right? So we have to calculate this integration of cosec squared 2x dx. So from the formula, we know that integration of cosec square x dx is equal to minus cot x plus c. Okay, this is a formula. Stuti, can you remember?
Okay. Yeah.
Okay, so but we have integration of cosec square 2x, right? Instead of x, we have cosec square 2x. So that's why we have to use substitution rule. Okay, so we substitute 2x is equal to t. Okay, so then we have to differentiate on the both side. So d2x, it will be 2x derivative dx. Okay, so derivative of 2x, it will be 2, so 2 dx. And if I take this 2 on the another side, so it will become dx is equal to 1 by 2 dt. Am I right?
Yeah.
Okay, so we found dx is equal to 1 by 2 dt. So now we can use substitution. Like we write here t instead of 2x. Instead of 2x, we write down here t, and then we had dx here, right? You see here we had dx. So instead of dx, we can write down 1 by 2 dt. Okay, so I write down here 1 by 2 dt. So then we have to take the constant out. We take the constant out, so we get half integration of cosec square t dt. So now we have to substitute back our t. So it is okay, so we have to calculate this part here. It makes a formula, right? It is according to this formula. Integration of cosec square t dt, it will be minus cot t plus c. Okay, and we can just multiply, we can just take this minus here. So ultimately the answer is minus cot 2x plus c.